LHS?
Yes.
So LHS equal to RHS. So this is indeed the solution. So this,
2 মিনিট বাকি 2 মিনিট পর যাচ্ছে
so
মানে
this is indeed the solution. Do you all agree?
Yes, sir. Yes, sir.
Right. So what is the solution of this differential equation? So let me erase everything and move on. Yes. So I have written as a cos kx. So doesn't matter. A and b are constants. Oncon, mute yourself. So instead of A and B, I have just interchanged it. Now doesn't matter. A and B are constants, which we will be finding out in a moment. So this is the solution to the differential equation. This is the solution. Now, how many unknowns are there, students? How many unknowns are there?
3. A, B, K.
A, B, and K. Right. So A, B, and K. But even since you have solved differential equation, you know that in a differential equation can only be solved, unknown constants can only be solved if there is boundary condition. You remember that initial condition or boundary conditions?
Yes, sir. 0 to L. 0 to L.
No. 0 to L is the boundary for X. Now, if at the boundary, how will eta behave? Can anybody think of that? Okay, think about it. We have 10 minutes left. You will join using the same link. But for the timing, I'll take the attendance first. So you think what will be the boundary condition? And I'll take the attendance. Yes, you have done this in your chemistry. So you have done this in your chemistry. So I expect better answer. What will be the boundary condition? Okay, okay. Am I audible?
Yes, sir.
Okay. Okay, so what are the boundaries? So yes. Now tell me, what is eta? As such, what is eta? What is eta? Isn't, yes, but physically, what is eta? Isn't eta a part of wave function?
Yes, sir.
Yes.
And then what will be mod of eta square represent? What will mod of eta square represent? You remember that?
Probability.
Probability.
Very good. Very good. Mod of eta square is going to represent the probability of finding the particle. Am I right?
Yes, sir.
Now
Yes,
tell
sir.
me, very good. Now tell me, what is the probability of finding the particle to the left of this 0, x equal to 0? What is the probability? Yes.
0.
Yes. Yes. And what is the probability of finding the particle to the right of x equal to L?
1.
No, no, no. The particle is between 0 to
Zero.
L. 0. Yes. The probability of finding the particle to the left of this x equal to 0 is 0. And the probability of finding the particle to the right of x equal to L is also 0. Am I right?
Yes.
Now, if the probability of finding the particle to the left is 0, what is the probability of finding the particle right at the boundary? Just to the left. Please understand it in terms of mathematics. You have studied limits. No, 0. Boundary.
L টা 0 হবে।
L क्यों 0 होगा? L is the width of the box. L is the width of the box. Why would L be 0? The particle is constrained. The particle is restricted to move within x equal to 0 and x equal to L. That's it. What is the probability of finding the particle just to the left of this boundary? Just to the left.
0.
Please understand. Okay, please understand. This is the boundary. I am only drawing the left boundary. The probability of finding the particle to just to the left of the boundary is 0. This is the 0 line.
minus.
This is the 0 line. If the probability of finding the particle at the boundary is not 0 but something finite, let's say this height is the probability, then isn't there a discontinuity of probability at the boundary? Yes. Let me rub this. What did I say about some of the properties of wave function? Do you remember? The wave function must be continuous, single valued, differentiable. You remember that?
Yes, sir.
Now, please understand, if this is the boundary, it's much problem. I don't know where I kept my writing tab. This is the boundary. If the probability if the probability of finding the particle just left of the boundary is 0, this is the probability P equal to some value 0. This is 0 line. And let us say at the boundary, just at the boundary, it is not 0. It is something like this. Whatever. The wave function is something like this. So it is not 0 at the boundary. Do you see this? It is not 0. So can you see that the wave function eta has a discontinuity at the boundary? Can you see? That is, what do I mean by discontinuity? By discontinuity, I mean there is a sudden jump of eta. Eta suddenly jumps from 0 to a value that is not 0. Am I right?
Yes, sir. Yes, sir.
Which cannot be true. Which cannot be true. There cannot be a sudden jump of eta. There cannot be a discontinuity of eta. Eta has to be smooth function. Sudden jumps नहीं हो सकते eta में. Eta एकदम smooth function होना चाहिए. तभी तो वो continuous होगा. Am I right?
Yes, sir.
So if it is 0 just left of the boundary, then what is the value of eta at the boundary? 0. 0. Am I right? Right. So let me erase this. So what are the two boundary conditions? So the boundary condition is first boundary condition, kar lete hain. At x equal to 0, eta will also be equal to 0. Am I right?
Yes.
Yes, sir.
Yes, sir.
If this is true, this is the first boundary condition, students. This is the first boundary condition. If this is true, then just put the value of x equal to 0 over here. 0, 0. What is this term? Sine of 0? Sine of 0 is 0. Am I right? Yes. Cos of 0 is 1 and eta is 0. So what do you get? You get 0 is equal to a. Am I right?
Yes, sir.
Yes, sir.
So you have found out the first unknown value. A is equals to 0. Is it okay?
Yes, sir.
Yes, sir.
Yes.
So what are we left with? Now what is the equation? Now finally our equation is A is equals to 0. So eta x would be B sine kx. Do you agree?
Yes.
Yes, sir.
Because from the first boundary condition, we have found that A is equal to 0. So eta x now is equal to B sine kx. Only the sine part remains. Now let us put the second boundary condition.